concating data frames. When I say concating, what exactly it is? Suppose a client has given you different files. Suppose say data frame 1, data frame 2, data frame 3. Right? He don't give exactly the data frame, he will give the files and all, but file operations and all we have not covered it. I'm going to cover very soon. So here we are trying to understand the basics of data frames. Right? Once we get the files, it is just a cakewalk, only one simple line of a code to convert into data frame. So you don't need to worry about it. Let's talk about, I have a multiple data frames. So I wanted to add all of them. I wanted to join all of them. Data frame 1, 2, 3, 4, 5, right? So how do I join them? Basically, there are a couple of methods. One is concatenating, concat, merge, and join. Right? We will see one by one how we can join the tables, or sorry, data frames one by one. Let's try to create one data frame first. So this is a math, that is maths actually, English, science, and chemistry. Right? So earlier what we were doing, we were creating the dictionary, right? Creating the dictionary, and we were calling that dictionary. So here what I did, I just given the dictionary right here. Instead of declaring and calling it, directly I have created dictionary within the data frame format here. So I will take this data and convert into data frame. Both are same only. Now one thing you need to notice here, index. We have seen the indexes, right? It will start assigning the indexes, right? By default, starting from 0, 0, 1, 2, 3. And I have also mentioned we can change these index numbers the way we want, maybe numbers or the strings, whatever you want to give, you can assign it. So how are we going to do that? So this is the parameter index that is available in data frame. So here Ravi, Sham, Farhad, and Abhi, right? So these are 4 students and their marks. Okay. So let's print this so that we can see this data better. So this is how it looks like. Ravi scored 40 in maths, 56 in English, 56 in science, and 44 in chemistry. Same thing goes for other students. Simple data frame. So here I don't have 0, 1, 2, 3 because I have overridden. If you want to change those default 0, 1, 2, 3 indexes, yes, you can mention index equal to your data, your index numbers or names or whatever you want to give. Fine, this is a simple one data frame. Similarly, I'm going to create one more data frame because we need multiple data frames to understand the join, merge, concat, right? So for that reason, I'm creating multiple data frames. In this data frame, I have different names. Shan, Mahi, Viru, Mona. Their maths, English, science, chemistry marks, respectively. This is the second data frame. And the third data frame looks like this, right? So Asta, Rohit, Rahul, Sheetal. So we have 3 data frames, DF1, DF2, DF3, right? So now all are different data frames. Now how will I be able to join them? Let's start understanding the concat. pd.concat. So what concat means? So it is going to concat all the data frames. So you can use concat if data frames are 2 or more than 2. Right? Here we have 3 data frames. The syntax is pandas dot concat. You have to pass your data frames as a list. That is df1, df2, df3. Right? So now I will talk about this axis equal to 0 and axis equal to 1. So first execute this so that I can explain better. So if you look into this, what happened? Here I am saying axis equal to 0 means first df1 data, then adding df2, then adding df3. So what is happening? So this is df1 structure, right? Let me write it here, df1 structure data, and on top of that I'm adding second one. Then on top of that I'm adding third one. So basically I am adding row wise. I'm concatenating along row, one below other. So because all these subjects are same in all the data frames, right? So you can imagine this, if I want to put it in some use case, suppose say in any college or any schools, right? You have a section A, section B, right? Say section A, section B, section C. So all are basically students of class say 10th, right? So you'll have different sections in different. So irrespective of the section, your subjects remain same, right? But students are different, right? In different sections. So yes, so this is how I will be able to join them. So this is the whole structure. What you see belongs to standard 10th or PU or first year, whatever you can interpret. However you are to interpret, you can interpret. But the idea is this one, so that you will get every student's detail for same subjects, right? That is the idea behind this concat. Fine. Now let's say that I wanted to concat column wise. So here we did a row wise, and let's see how it looks like when we try to concat column wise. So for that, I'm going to change the axis equal to 1. Earlier we had axis equal to 0, which is for row. Now I'm changing it to axis equal to 1 for column. That is the only change I have done here, nothing else. Let's execute. You see some weird kind of a data frame here, right? So what is happening here? How to interpret this? Why we see NaN and things like that? Now let's try to understand. This is a data frame 1, right? So this whole part is a data frame 1. Now, in the data frame 1, okay, let me print the data frame 1 so that we can interpret better. Data frame 1, right? Give me a second. Okay, so this is clear. So when you look into data frame 1, so what exactly it does whenever we're trying to do the operations on a concatenation, merge, or things like that, it will try to check the index data. Indexes basically. So here we have indexes Ravi, Sham, Farhad, Abhi, right? So now, so these indexes are related to data frame 1 only. So these indexes are not present in either data frame 2 nor data frame 3. So data frame 1 is printed. So this is basically what data frame 2 related data, but we don't have similar indexes. So what it is trying to do, for these indexes are not present in the data frame 1. So what it is going to do, it is going to change it or replace with NaN. It means that there is nothing. So if I consider df1, so this is df2, this is df3, right? So in this df1, do we have these indexes? We don't have these indexes in data frame 1. So when we don't have these indexes, obviously there won't be any data. So there, since there is no data, it is going to fill with a NaN. By itself, it will do, wherever it doesn't find the data, right? So now if I consider DF2, in DF2, only these indexes, let me print that here instead of DF1, what I will do, I will say DF2, okay. If you look into DF2, this is DF2. So here, what kind of indexes we have? Shan, Mahi, Viru, and Mona, these guys, right? So yes, we have these indexes, and those data or respective marks are printed here. In DF2, we don't have Ravi, Sham, Farad, Habi. Similarly, we don't have Asta, Rohit, Rahul, and Sheetal. So yes, it will be filled with the NA because it did not find the indexes. Similarly, it goes for DF3 as well, right? DF3. So it has only Asta, Rohit, Rahul, Sheetal. So yes, you see that data. And these indexes are not present in the DF3, so it will be filled with the NA. So now it is pretty clear that for sure you will be able to understand that. So which way is better? Which way is better? So obviously this way is better when you are trying to deal with this kind of a situation, right? It all depends upon the situation. So here I gave a students marks related. So this works perfectly fine. So access equal to 1 doesn't make any sense in this situation, right? So you can always try and see which one works best for you, depending upon the requirement, depending upon the situation. Whichever works best for you, we can keep that. It doesn't make any sense, right? Maths, English, science, chemistry, again, maths, English, science, chemistry, same thing. So it's repeated and we see some NANs. It is very difficult to interpret this, right? But the main idea is how to concatenate simple pandas.concat, pass your all the data frames and row wise or column wise. Only simple thing, right? Very simple. That's about a concatenation, right? So now let's say that, let me delete this. So we have all NANs, right? So we know how to fill the NANs. Let's finish that as well, right? So let's finish that as well. Instead of NAN, I wanted to fill that with the zeros, right? Even though you have millions of NANs, just by writing a simple line of code, this statement, right? So this is basically what? df underscore cat, the whole data set. Right? So that is what we have given the name here. I'll take this name, data frame name. I will say dot fill NA method, and I will say value equal to 0. So wherever it finds NAN, it will be filled with the zeros. I'm just filling it. So there is no meaning as such here because it doesn't make any sense. Here I'm trying to show you that how we can fill one more time. Right? So yes, in place equal to true means save the data set. As simple as that. Now let's run this. So all the NANs are filled with the zeros. Right? Now let's talk about merging. Right? So let's, for that we have to create 2 data frames. So I'm taking a different example now, right? So let's print a left data frame and right data frame, right? Simple data frames. Now index, we have not touched anything about index here. So here we have a key A, B, key C, D, different column names, right? Now, whenever you want to merge, you can merge only 2 data sets. 2 data sets, right? So when you have more than 2 data sets, yes, you can go for a concatenation. We have also one more example, like joining. So there also we'll see how to join 2 data sets. So merge is also one of the options that you can go for. Let's try to understand how merge works. These are the simple data frame we created. Now, how do I write the code for a merge? What is the syntax for that? Syntax is very, very simple. Pandas merge. That's all. Merge your data frames. So one is the left data frame we have created. Another one is a right, right data frame. So you can just mention these are the minimum requirements. If you want to customize this, if you want to merge differently, in different fashion, so again we have some parameters in it. How, on, we'll discuss that, right? So yes, left data frame and right data frame. So how and on we are going to discuss once we print this. Now let's run this. So what happened here? So here we have a key A, B, C, D. So first of all, how many columns we have? You can see here it is, give me a second. Key A, B, key C, D. So basically key is the common here, right? Key is the common and A, B, C, D, right? So now if I look into this merged or the result of this merge, key A, B, C, D, A data is there, B data is also printed, similarly C and D. So here we have K0, K1, K2, K3. Here also we have K0, K1, K2, K3. Right? It means that keys are same. Keys are same. When the keys are same, why I'm talking about a key? Because on the key basis, I need to merge. On what basis I need to merge? I am saying on key basis because we already have a key as one of the column. On this basis, I wanted to merge. Right? So then what about inner? So inner means whatever is basically matching. The data which are matching. So yes, K0 is matching. When I compare to left and right, it is present in both the frames. K1 is also present in both the frames. K2 is also present in both the frames and K3. Right? Wherever it is matching, it is going to display those keys and corresponding A, B, C, D, all those data. So now you may ask, what if I put something else here? The result is again, it is going to give the same thing, like NaN, what we discussed. Matching records will give the data, and if it is not matching, so what happens? It will give you NaNs, same concept. Right? So if you don't give anything here, what is going to happen? Nothing. Because those are the default values. How? Inner means, so I think we discussed about an inner join and things like that in the SQL part, right? The same concept applies here. Nothing difference. Inner means all the matching data. So when I say matching data, matching with what? Matching with this key. That also I'm trying to mention in this parameter. So you can give different keys here and try to explore how is equal to outer and things like that. So you will be able to see similar type of a result. The matching will have a data, non-matching will have NaNs. Right? So if you understand this concatenation, so most of the merging or joining, they're all on the same line, nothing much difference. Only thing is that when you are using a merge, keep that you can have only 2 data sets. If you have more than 2 data sets, we have different methods, which we discussed. Similarly, join operators. So let's execute this. Now, if you observe here, I am giving my own index names. Here it is a little different. Okay, let's print this. So I will show you what is the difference. left and right. So here you can see in the left data frame, this is left data frame, okay? So K0, K1, K2, that is the left data frame. And in the right data frame, we have K0, K2, K3. So basically here K1 is missing, here K3 is missing, right? Because we cannot expect all the time data frame will match, right? The keys will match. It's not mandatory that they should match, right? So if you have this kind of a situation, so how do I use these data frames and try to, how do I join them? So let's try to understand. So now I'm going to talk about a join here. So what are the data frames we have with us? Left data frame. You can give any name, your wish. I'm just taking this example, left and right. Right? So I am saying left. Suppose if you are using a df1, just use a df1, right? Okay. Left data frame dot join. Which data frame I need to join? Right data frame. So take this guy and join with this guy. When I say left dot join right, it means that left data will remain same. So basically I'm saying that was right data frame, you go and adjust with the left guy. So left will not change. Left data will remain same. Only right guy, whatever the data in the right data set, whichever are matching is going to be adjusted with this guy. He is going to join this guy. So as the name says, join means go ahead and join with this guy. So let's print this. Now let's look into this. When I say left will never change, right? You can see what is the left. This is the left guy. K0, K1, K2. K0, K1, K2 indexes. So AB never changed because it will remain same. This side, left guy. So since I have joined right to the left, so CD for these two columns or for this data frame, what are the matching indexes? K0 and K2, right? K0 data and K2 data. Since right data frame doesn't have a K1, right data frame doesn't have a K1, so what it had, what it filled with a NAN, because it's saying I don't have K1 with me. So what I should do? So I will fill with a NAN. Right? Let me repeat this once again. I will clean this up. This is our left data frame. This is our right data frame. So I'm saying go and join this guy. So when this guy is going to join, this guy will never change because this guy has to adjust. He is joining this guy. So when he is joining to the left, so he will join based on the indexes in the left data frame. That is why you don't see this K3 here. You don't see any K3. Right? So that is the idea here. Left dot join. If we change this to right dot join and left, you can try that. So there you will see K0. So I will just rewrite here K0, K2, K3. So this complete data set you will see C0, C2, C3 and C and D. And when it prints AB columns, so there you will see K3 NAN. I want you guys to try whenever you are practicing. Right? That is the idea behind this join. Now, if you want, no sir, I want to print everything. I want to print everything. So then you can say how equal to outer. So by default here we did not mention how, right? If I don't mention how parameter, by default it will take a inner. How do I know the by defaults? Yes, I have mentioned a couple of times. Keep your cursor inside this parenthesis and press shift tab. Sorry, how is equal to left is the default one. How is equal to left is the default one, where left data frame will remain same. So if you want to override this, yes, you have to mention this how is equal to outer. When I say outer, it doesn't matter what data you have in the right or left. Whichever is matching, that will write. You can see here, right, all the indexes. K0, K1, K2, K3. Whichever indexes are matching, it will write the data. Wherever it is not matching, it will just fill with a NIN. Here you will have a glimpse of the entire dataset result. Or left and right datasets result. The matching records will be there and non-matching records also will be there, but filled with the NINs.